Okay, so the second thing we're doing this week is some new learning, and that is writing formulas for ionic compounds. This is not too hard. We've actually done a little bit of it already, so it should be like, oh yeah, I've kind of seen this. For this one, there are actually two worksheets. Neither of them is very long. I think they have like 12 or 13 questions each. And then there is quiz number 7. Okay, so we are going to get going on how to write formulas. So let's give that a go. And I just need to pull up my examples here. Okay, so for example, we are going to start with Na, whoops. Okay, let's do a different one. Lithium chloride. Okay, so step 1 is you write down the ions and their charges. Okay, so I know that lithium is Li, and I know that chloride is Cl. If I don't know the charges for those, where do I look? If I don't know the charges for my ions, where could I look? I could look on the polyatomic ion chart if they were polyatomic ions. These ones, though, Li has only one capital letter, and so it is not going to be a polyatomic ion. So we're going to look on the periodic table. So you're going to use the polyatomic ion chart for polyatomic ions, and you can use the periodic table for monatomic ions. Okay, so let's go take a look at our periodic table. Okay, and let's go look at lithium. Lithium is over here. Now, you can write these charges on your periodic table or you can memorize them. Memorizing them is a good option, but it's not required, okay? Really, it's as easy as 1, 2, 3. Charge of column 1 is +1. Charge of column 2 is, guess what? +2. And the charge of column 3 is +3. Okay, so again, like I said, it's as easy as 1, 2, 3. And this one's particularly easy because group 1 is +1, group 2 is +2, and group 3 is +3. And that's because group 1 contains 1 valence electron, so it will lose 1 electron, become +1. Group 2 has 2 valence electrons. It'll lose those 2, become +2. Group 3 has 3 valence electrons. It'll lose those 3 and become +3. Okay, so you've got +1, +2, +3. Over on the right-hand side of the periodic table, we do virtually the same thing, but we start at group number 17. Group number 17 is -1. Because it's lacking 1 electron, it'll gain an electron to get that full shell. Group number 16 is -2, and group number 15 is -3. So again, it's as easy as 1, 2, 3. Okay. Yes, Andre, we're going to get to those in just a moment. Boron itself isn't plus, yeah, it's not really +3 because it doesn't have a tendency to form ionic bonds. It tends to form covalent bonds, and thus it does not have a charge. Now, everybody in the red zone is a big mishmash. We don't know. We have to look at the Roman numeral to know the charge, but you'll notice there's this little area in here. Okay, right over here, there's this little mini staircase inside this section here. And amazingly enough, this is still as easy as 1, 2, 3. And if you look at it in this column here, there's only one element, that's silver. Silver is +1. In this column, the column with zinc, there are two elements that are not in the red zone, and their charge is +2. And then in the aluminum column, the boron column, these guys, there's 1, 2, 3 of them, and they are +3. So again, it's as easy as 1, 2, 3. Like I said, if you can memorize it, that's great. But if you want to write them on your chart so you have them to refer to, that's also okay. Okay, so we were dealing with lithium, and lithium is +1 because it's in group 1. And we're, excuse me, dealing with chloride, which is in column 17, so it is -1. So we will now go back to our question and we'll say, I have lithium, which is +1, and I have chloride, which is -1. So step 1, write down your ions and their charges. Step 2, make the total positive charge equal the total negative charge. And guess what? In this case, oh my gosh, they are already equal. A +1 is equal to a -1. Those will cancel out and give us 0, because remember the net charge or the overall charge, whoops, overall charge of a compound should be 0. So we want the positives to cancel out the negatives, and in this case they already do. So what I'm going to do is then I can write the formula of my compound as LiCl. And because there are no subscripts, that means that there is one Li plus ion and one Cl minus ion. Okay? One thing I want you to notice is that when you write the formula of the compound, I don't want to see the charges. Okay? Do not write the charges in the compound. So I guess step 1, write down the ions with their charges. Step number 2, make the total positive equal the total negative. And step 3, write the formula without the charges. Okay? So lithium chloride, that was a pretty straightforward example. Let's try something a little more complicated. Potassium nitride. All right, potassium is an element, nitride. When you see the ending IDE, does that make you think of a polyatomic ion or does that make you think of a monatomic ion? Ions are usually something atomic. Are they usually polyatomic or are they usually monatomic? Yeah, they're usually monatomic. Okay, so what that means is that I am looking at potassium, which I happen to know is K, and I'm looking at nitride, which I happen to know is N. I can go look up their charges on the periodic table. Potassium is in group number 1, just like lithium was, so again it is +1. Nitride is in group 15, so it's going to be -3. So we can go put those down on our ions here. So potassium is plus, which means +1. Nitride is 3 minus. So step 1 is to write the ions. Step number 2 is to make the total positive equal total negative. Do they equal each other right now? Do the positive charges equal the negative charges? No, no, they do not. So I am going to need more positive charge because right now I've got 3 negative and only 1 positive. So if I add 1 more potassium, that gives me 2 positives, still not quite enough. I'm going to add a third potassium, and that's going to give me a total of +3, which is equal and opposite to my -3. And now I have 3K ions, and I have 1 N3 minus ion, and I show that in the formula by saying K3N. 3K ions, and no subscript means there's 1 N ion. Okay, let's try one that's a little bit trickier. Iron 3 oxide. Now I'll let you know the most tempting things that people do. Scandium silver, that would be 2 metals together. We can't do 2 metals together because they both want to give away electrons, and so there would be no one to take them. Okay, so iron 3 oxide would be, um, lots of people might be tempted to do this. These are things that you should not do. Do not do um, these. Hang on one second. There we go. That's better. Okay. First one that you don't want to do is you do not want to say iron is Fe and stick a 2 in there and put an O. You should never have a Roman numeral in your formula, only in the name. Numeral, I forgot my L, in the formula, only in the name. Yep, that's what it says. It says iron, oh, iron 3. Well, you wouldn't want to do it as iron 3 either. There we go. Certainly wouldn't want to do it as iron 2 because then it would be completely wrong. Okay, second thing you don't want to do is you do not want to go iron 3 oxide. The Roman numeral 3 does not tell you the number of ion atoms. Or iron ions. Okay, so Rather than doing all that and just looking at the name and going, woo, I'm just going to get right to it, you're going to remember my first step is to write the ions. And so we have iron, which is Fe. Now it's in the red zone, so we wouldn't be able to tell its charge by looking at the periodic table. How do we know the charge of iron? How do we know the charge of iron? Yeah, it is exactly from the Roman numeral. So here's our Roman numeral. Okay, and so that charge right there is going to tell us that it is iron 3 plus. Oxide, I'm going to cheat. I'm not going to open up the periodic table. I'm just going to tell you that it is 2 minus. Now, there's a couple ways to do this. You can simply add ions until everything equals out. I can look at this and say, I don't have enough negative charge yet. My negative charge is too small. So I'm going to add another oxide. Now my positive charge is too small because I have positive 3 and negative 4. So I'm going to add another iron 3 plus. Now my total positive charge is positive 6. So now I need to add one more oxide, which will give me negative 6. So I have negative 6 to balance out the positive 6. So you can do it that way. You can just add on either anions or cations, whichever one doesn't have enough charge, until they eventually equal out. The other way to do it, and some of you may have noticed this for yourself already, is to find the lowest common multiple, the LCM, lowest common multiple of the charges. In this case, we have a 2 minus and a 3 minus. So in this case, the LCM is 6. The lowest common multiple is 6. So I need 2 of the irons to give me 6, and I need 3 of the oxides to give me 6. Okay, so we've written our ions. We have balanced the charge. Which means our total positive is equal to our total negative. And when I say equal, I mean equal and opposite. Okay. And now we just write the formula. We write the formula. And remember, no charges in the formula. So we're going to write it as Fe. What's going to go beside the Fe? What number? Yeah, it's going to be a 2, okay? Because we have 2 irons, 2 Fe's, and so we're going to need a 2 there. And for the oxide, there are 3 oxygens. So when we write our O, we're going to have O3. Okay, and make sure again that you're writing these as subscripts. So other things not to do, you're not going to write it as Fe2O3 with the numbers up top. The numbers have to go at the bottom. You're not going to write it as Fe2O3 with big numbers, okay? The numbers have to be subscripts. Okay. Now, when you go to do the quiz, sadly, this breaks my heart, the quiz won't let you subscript things. So when you're doing the quiz, you will be doing it this way. But just bear in mind that when we get back into the real world and you write things down by hand, it is not going to be Fe2O3, it's going to be Fe little 2 O little 3. Okay, so yes, on the quiz, you're going to have to write it like this, but normally you wouldn't. Pardon me. Okay, let's do a couple of examples with polyatomic ions, and then I will send you on your way out into the big wide world. Okay, examples with polyatomic ions. Okay, sodium acetate. Sodium acetate. So the first thing you want to notice with this is that you have that ending 8. When you see the ending 8 or ite, you know you have a polyatomic ion. Okay, and what that means is that you are going to check your polyatomic ion chart. Polyatomic ion chart. So let's go and just look up acetate on our polyatomic ion chart. Okay, make it a bit bigger. These are alphabetized, which is sometimes helpful, mostly. Here is acetate, and its formula is CH3COO, and it has a -1 charge. So we can go back, and acetate is CH3COO with a -1 charge. Sodium, that's a metal, and it's a non-red zone metal, so it's Na. It's in column 1, so its charge is +1. So I've written my ions with their charges, and oh, look, my positive equals my negative. So the formula then would be NaCH3COO. Okay? And I want you to take notice, there is only one acetate ion, and therefore we do not use brackets. We'll see brackets in the next example. Some people get really excited about the brackets and they want to put brackets around everything. So we're only going to use them when we have more than one of a polyatomic ion. Here we have only one polyatomic ion, so do not use the brackets. Okay. Let's try another example. Copper 2 hydroxide. Okay, well, copper, I know that the formula for copper is Cu, and the Roman numeral tells me that it is 2 plus. Now, hydroxide, I look at that "ide" and I think, oh, very often "ide" means that it's monatomic. However, this is one of the exceptions to "ide" being monatomic. So it's an exception to the monatomic "ides." There are 2 exceptions. Those 2 exceptions are hydroxide, which is a polyatomic ion, and it is OH minus. Okay. Exception number 2 is cyanide, And it is, again, a polyatomic ion, and it is Cn minus. Oh, there's one other one I forgot about it. Oh, gee, there's a third exception, and that is bisulfide. Bisulfide. And if you remember, if we have that bi at the beginning, that means we attach an H plus. So we're attaching an H plus to a sulfide. So together, those are going to make, it's a polyatomic ion. That's going to be HS minus. So just watch out for those ones. I'd almost always means monatomic, but not for these three exceptions. So take care when looking them up. So hydroxide, let's go look it up on our polyatomic ion chart. Okay, it is an anion because it came second in the formula. Oh, there it is right there. It is OH with a -1 charge. So hydroxide is OH -1. Do the positives equal the negatives? No, they do not. So the second thing we're going to do is we're going to balance the charge. We're going to make our positive equal our negative, and we can do that by adding one more hydroxide. Okay, so at this point we now have 2 positive, which is equal to 2 negative. Yay. And the third thing we're going to do is write the formula, and remember, no charges in the formula. And so that's going to be Cu, and then we have OH2. And I'll let you know right now that I have done something wrong. And I'm wondering if anybody knows what I have done wrong. Yes, I need to have brackets, absolutely. Because that formula, the way I've written it, it means I have one Cu, which is true, right? I've got one Cu. It says I have one oxygen because there's nothing written beside the oxygen. One oxygen. But uh-oh, up here I can see I have two oxygen. Two oxygen. So this would be wrong. Okay, I need to have the brackets around the OH in order to say I have both two of the oxygen and two of the hydrogen. So you must use brackets if there is more than one, or if there are two or more of a polyatomic ion. Good question. Is CuO2 H2 valid? And that answer is no, it is not. The reason for that is that we want it to be very clear that OH is a special unit. Okay, so you can imagine if we had a copper, it might have a hydroxide on this end, and it could have a hydroxide on the other end. Okay, and this is very definitely a group, and this is very definitely a group. But if you had CuO2H2, it could be that you had a copper and you had an oxygen, and then over here somewhere else you have a hydrogen, and the oxygen and the hydrogen wouldn't necessarily be with each other. So we always write polyatomic ions together as a unit. Okay? Polyatomic ions always as a unit, and then we always use the brackets to multiply them. Use brackets to multiply them. Okay. Whoops. So I got halfway through that sentence. Let's see. Must use brackets if there are two or more of a polyatomic ion. Okay. Let's do one more. That's a little bit strange. Okay. Let's do lithium, hydrogen, carbonate. Even though there are three names, there are only two ions. Andre, what's up? You have a question? Nope. Okay. Lithium hydrogen carbonate. Um, so even though there's three names, there are only ever two different ions. Okay. And so there's going to be the cation, which in this case is the lithium. And what that means is that everything else has to be the anion, which means you can go look up the name hydrogen carbonate. That's okay, don't worry. Hydrogen carbonate on your polyatomic ion table, and it will show you one group for that entire thing. Okay? So you're going to look up this whole thing on the polyatomic ion chart. Polyatomic ion chart. So let's go do that. Let's go look up hydrogen carbonate. Okay, it's going to be under H. And there it is right there, hydrogen carbonate. One thing I'd like to remind you of is that you can choose for HCO3 minus whether you call it hydrogen carbonate or whether you call it bicarbonate. You get to pick one or the other, but not both. So if you're actually doing the naming, choose one or the other. Okay, so now we have found hydrogen carbonate is HCO3 minus. Go back here. So our cation is lithium. It's in column 1, so it's +1. Hydrogen carbonate, we looked it up, it was HCO3 minus. And that means, oh, look, +1 and -1. My charges are already balanced. My positive cancel out my negative, and so I would just write LiHCO3. And remember, there's no brackets because there's only one of the hydrogen carbonate. Okay. How are we feeling? Would we like any other examples? Anybody? Or are you feeling like you'd like to go give it a try? Okay. Well, I'll tell you what, if you feel like you're good at this point, then you can feel free to leave this meeting. Don't forget we have I'll get it Applewood. I like it. You can feel free to go and check out our assignments online. This week there are two of them, like I said, 6 and 7. Okay. I would break up the assignments if it were me. I would be like, okay, I would do worksheet 6, and then I would do quiz 6. And I might do this day 1, and I might do this day 2. And then on day 3, I might do worksheet 7A, and then on day 4, worksheet 7B, and on day 5, I might do quiz 7B. But if you have a larger chunk of time, you can you can, put more together. It's really up to you, but try not to do too much in one day or you'll burn yourself out.